Hello everyone, my name is Pierre Verbist. I'm a teacher but also a STEAM trainer in Belgium. I'm delighted to be with you today to present this video about Thymio and the microbit card. Let's first discover how to connect the two. First of all, the procedure and all the files needed to connect can be found at the following address. Once arrived on this site, 3 steps will have to be done. First step, you will have to prepare the computer so that it can communicate via Scratch with the microbit card. To do this, you must install the Scratch Link program. Choose your operating system from the options provided. Windows, Mac OS, Chrome OS, and even Android. With that done, you can now move on the next step. Second step, you need to prepare the card itself by installing a small file. First, make sure that the card is connected to the computer with a USB cable. Next, download the small HEX. Then, transfer this file to the card. Once this is done, it should indicate a word, its name, continuously. This will allow you to recognize it during the Bluetooth connection. Third and last step, it is almost ready. We still have to install the extension in Scratch. Open the Thymio suite, choose Scratch, and then the robot you want to program. Once in the Scratch interface, you will now add the microbit extension. This is located at the bottom left of your screen. From the list of extensions that can be added to Scratch, you can select the extension you want. If you have followed the steps above, you should see your card and its name in square brackets. Click on Connect and go to the editor. And now you have all the blocks you need to program your card. After this somewhat technical part, I will now present the activities that my students were able to do this year. Here is the first sequence, a simple little program. This is the first challenge I offer to my students. Use the physical buttons on the board, A and B, to make the robot move forward or stop. When button A is pressed, it will move forward at a certain speed. When button B is pressed, then it will have to stop. Let's look together at the result. It's very simple, but already a lot of fun for the kids. Believe me. Here is the first great activity I was able to do with them. Remote-controlled Thymio. In this activity, the card controls the Thymio. The basic challenge was to use the accelerometer of the card to guide the robot. a little bit like the game controllers of famous Japanese consoles. The inspiration came from another activity on the Thymio website where, on the same principle, a Thymio guided another one, as you can see on the picture. In order to help the children to visualize what they had to realize, I prepared this small demonstration. When the card is tilted forward, so Thymio moves forward. When tilted backwards, Thymio goes backwards. If you tilt it to the side, Thymio turns. Here is a draft of a program made by a student at the end of the first sequence. Now let's look at the result of this little program. Isn't it amazing? I would like to present you now the future activities that I have prepared for this year with this group of students. Here, in relation to the activity they have already made, we are going to ask the Thymio to interact and send information to the microbit. My idea is to present the famous racetrack that we receive with the Thymio, and to program two activities, first the lap counter and then the stopwatch. I've already prepared a rendering for my students of what it should look like. First, we will have a Thymio that they will have to program to complete the lap inside, between the black lines, so in the white part. This is an activity they have already done. And then we will come and place another Thymio in the place where the image of the lap counter is on the mat. This one will be connected to our microbit card and it will display the number of laps made by the Thymio. I will then organize a competition by team, the first one who succeeds in making 5 turns. Knowing that the more refined the program of the Thymio that runs, the faster it will go to complete its turn. In a second step, I will propose them to realize the following project, the stopwatch. This one is more technical than the lap counter, and therefore presents a nice progression, a nice challenge for them. Third project, the idea is to completely link the two systems. So, to really have a bidirectional communication, to send information from the Thymio to the card and from the card to the Thymio. And so for this, I have come up with a little new activity, the red light, which I will present to you. First of all, there will be a black line which will symbolize the stop sign, and a red light. I'll still need to think about this activity. Will I use a real traffic light, since we can connect small elements on the cart, or just use a system of symbols? Either way, the flow should be like this. At the beginning, the light is connected to microbit and the light is red. The Thymio reaches the black line. There is a first request that will be made to see at the level of the car. Is the light red or green? If it is a red light, obviously the Thymio stops on the line. As soon as the light turns green, the card will send an information to the Thymio and it will start again. The desire here is clearly to create a system of transmission and reception between the two. I send an information, I receive it, I send a new information, etc. Before ending this video, I wanted to share with you this simple but very useful little creation, a 3D printed support to hold the card in the pencil hole on the Thymio. If you want to print it too, you can find this model on the Thingiverse platform. Merci de m'avoir écouté. Une fois de plus, je suis vraiment ravi de partager avec vous mes expériences avec le formidable robot Thymio. Et à bientôt pour de nouvelles aventures.